Hello friends, and as can be seen from the video, today I am going to introduce you to a new concept known as the linked list. So linked list is a type of data structure which can be used to implement other types of data structures such as stacks, queues, and trees. Now, why we need linked list? So, we know that array is a linear collection of data stored in consecutive memory locations. But the main problem of an array is that the size of an array needs to be defined in the beginning itself. For example, if there is an array by the name A and we need 10 memory locations for the array, so we need to define the size of an array A 10 in the beginning itself while coding the program. Now if another data, that is 11 data set, comes in while the program is executing and there is no space in the array, the system will throw an error and the program won't be executed. So this is the problem of an array. If there is a dynamic program where we don't know the size of the data that the program will be using, then an array can cause a serious error. So this problem is solved by using linked lists. So now what is a linked list? So a linked list in simple terms is a linear collection of data elements just similar to an array. Now these data elements in a linked list are known as nodes. As I've stated, linked list is a data structure which in turn can be used to implement other data structures such as stacks, queues, and trees. Now this is the basic structure of how a linked list looks. There is a header node known as the start node. Then there are each individual nodes containing two parts. One is a data part and the other is the pointer part. The data part of a linked list or of a node is where the actual data is to be stored, and the pointer part points to the address of the memory location of the next node in the linked list. Now this might seem a bit confusing in the beginning, but I'll make sure you understand it properly. So I'll break this down into smaller parts. So now let's begin. The first is the start or the header node. So as we have seen it previously in the linked list, there was a start or header node. This header node points to the first node in the linked list. Now each linked list contains a header node. The header node points to the beginning of the first memory location of the linked list. And remember, the entire linked list can be traversed using the header node. Now remember, if the header node is empty, it means the linked list is empty. Next, we begin by knowing what is an individual node in the linked list. So this is the structure of how an individual node looks in a linked list. It contains two parts as I have stated. The first is the data part, which contains the actual data which is to be stored in the linked list. As in our given example, A is the actual data to be stored in the linked list. The second is the pointer part, which contains the address of the next node in the linked list. Now this pointer contains the address of the memory location in which the data of the next node is stored. So this points to the memory location of the next node's data. The last is a special type of node in a linked list known as a terminal node. This structure of a terminal node is similar to a normal node in the linked list, except that instead of the pointer part, it contains a null value in the end. Now this null value is used to denote that we have reached the beginning of the linked list and we need to stop traversing here. Now please note there are special linked lists which do not contain a null at the end. Such type of linked lists are known as circular linked lists, where instead of having a null at the end, the pointer points to the memory location of the first node in the linked list. Thus, such type of linked lists can be traversed infinitely using the pointers. Now these are the various type of linked lists. So as I've stated, circular linked list is a linked list where the last node does not contain a null pointer, rather it points to the memory location of the first node in the linked list and hence can be traversed circularly infinitely. Next is a doubly linked list. Now as you stated or seen in our example, the linked list contains pointers which points only in a single direction. That is, the linked list can be traversed only from the starting node to the ending node. But there are certain linked lists known as doubly linked lists where the traversal can be done in both ways, that is from start to end or from end to start. Next is a circular doubly linked list. It is a combination of the circular linked list and doubly linked list. That is, it can be traversed in both the ways as well as there is no null pointer at the end, rather the pointer points to the first node of the linked list. Thus it can be traversed in both the ways as well as circularly. The next is a special kind of linked list known as a header linked list. So a header linked list contains a header node before the first node of the linked list, and the start node points to this header node rather than the first node of the linked list as we have generally seen. The next is a multi-linked list. Now this is another very special kind of linked list where rather than having one or two pointers, there are multiple pointers for each node which point to multiple nodes in the linked list. Thus, from one node, multiple nodes can be traversed in the linked list. Such type of multi-linked lists are used to generate trees and all. Next, there are a few important points regarding linked lists. As I've stated, linked lists are a dynamic data structure wherein the memory size of the linked list can be decreased or increased as and when required, unlike arrays where the memory size is fixed. This is what the second point states, where you can add and delete data as and when required, unlike arrays where the data limit is fixed. Now, applications of linked lists include polynomial representations. Now, these applications will be covered in my further videos. Now, they are also used for implementing other data structures such as stacks, queues, and trees. Now, all the types of linked lists that I've explained previously will be covered in my subsequent videos, as well as the various concepts such as adding nodes to a linked list, deleting nodes in a linked list, as well as traversing a linked list will be covered in detail in my upcoming videos. Thank you. Please do like, share and subscribe if you have enjoyed watching the video. Now these are a few of the other videos from my channel. You can watch these as well and clear all your basic doubts regarding data structures. If you have any doubts regarding linked list or the concepts I've explained in this video, I will be happy to explain it to you. Please do feel free to post your comments and doubts in the comment section below.